Transportation infrastructure includes roads and sidewalks, railways, walking and cycling paths, and airports. We typically design transportation infrastructure for a static climate, but we need to start thinking about the changes that are occurring and that will occur in the future. It's important to think long-term for large infrastructure, as much of it is designed to be operational for long periods of time, often over a century. As an example of thinking into the future, Confederation Bridge, which links Prince Edward Island to the mainland, was designed to account for 1 meter of sea level rise. In Prince George, previous observations and research tells us that the climate is changing. Transportation was identified as the third highest priority area to be affected by climate change in Prince George. How a city's transportation infrastructure is designed, built, used, and maintained is affected by the natural environment. Winter road maintenance is a high priority for Prince George residents and a significant and rising municipal cost and safety concern. In the spring of 2011, experts from the University of Waterloo came to Prince George for a workshop to discuss how climate change could be impacting transportation in Prince George. 2 main categories for research were selected by a Prince George steering committee. The first priority was road design and climate change.
So a lot of the work is really we're trying to determine what the weather patterns will be in the future, and then how do we design our infrastructure to withstand some of those freeze-thaw cycles and warmer temperatures in summer or higher amounts of rain. That pavement structure, in my case, is really what we start to look at. It will be more likely to be distressed, will have potholes because of those changes in temperature, as opposed to traditionally where the weather dropped, it might stay at, say, -30, but it stayed at that level. So really what it's resulting in is changing the way we design our roads and also the materials we select. So maybe in the past we might have been able to get away with using some of the more local or traditional materials. Well, now we're going to have to add some engineering, we're going to have to do some more engineering and add some more different kinds of materials, maybe some additives to those pavement structures so that they're strong enough to mitigate these cycles. One of the really unique design processes that we've been looking at is the use of pervious concrete. Now there's also different types of porous asphalt and permeable pavers, but the pervious concrete is really unique because you essentially design it so that all the stormwater management is facilitated underneath the pavement structure. So you build it that it's very open and porous so the water drains through, and then you have a reservoir layer. So your water actually sits in that layer and then eventually drains down back into your subgrade. We found one of our test sections is in Montreal, which is really harsh conditions, lots of freeze-thaw cycles, and we're showing that it does work.
The other priority selected by the steering committee relates to winter road conditions and maintenance. This is important to ensure Prince George is prepared for any potential changes that could affect road safety.
We know that the most important societal adaptation to winter driving is snow and ice control, and of course all cities, including Prince George, have invested a lot of time and resources into developing programs that are effective. And these programs are always evolving. That's true in your city, and it's true in every city. In the next phase of the analysis, we'll be looking at how climate variability and change might influence collision patterns in the future up to the 2050s. We'll be looking most carefully at the intensity of events, heavy snowfalls, for example, and even heavy rains in the winter season. That's because we know that intensity matters, and we also know that conditions that create freeze-up, for example, rain followed by low temperatures and snow, are particularly problematic. So that's where we'll be focusing our attention. As climate changes in the future, we believe that there's reason to be proactive in understanding what that'll mean and developing programs accordingly.
Future opportunities include looking at climate change impacts in areas such as pedestrian safety and salt use, which will help the city to continue to be a leader in transportation management and planning.